All right, so I just want to thank you all for being here. I'm very excited to present what I worked on and everything I learned during my project-based internship in the Laboratory of Applied Informatics Research, directed by Dr. Mostafa. This project was given the name Analyze Med with the aim of designing an accessible system for adverse pharmacogenomic information, specifically within the African American population. So just to start us off, I want to give a brief overview of what I'll cover. So I'll start with some background information about the project and the inspiration for the overall system. I'll then talk about the methodology for designing the information system itself. Then we'll talk about several use cases that were defined for our end user groups, as well as the user interface and user experience requirements that came about to fulfill those. I also have a couple short demonstrations, screen recordings to just give you all a brief idea of how the system works in its current state. And then I'll conclude with some of the ideal next steps and future applications for this system. Okay, so to start, this field was very new to me, so it was important to gather a general understanding of pharmacogenomics and its potential applications at first. So what is pharmacogenomics? Well, it's the area of healthcare that examines how individual genetic variants can influence response to medications. Traditionally, many medicines may have been prescribed with a one-size-fits-all mentality. However, while doctors are well aware that things like age, diet, gender, things of that nature can affect drug response, it's not nearly as often that a person's genetic profile is considered and how that might affect drug response. And studies like the Human Genome Project have shown that genetic profile can have a tremendous impact on things like predisposition to various diseases. It can also call for a higher dosage of a medication or even lead to an adverse reaction with a particular medication. And this is actually where something called single nucleotide polymorphisms come into play, or also SNPs for short. And these are basically just small changes in a person's DNA. And they're considered SNPs if they occur in significant proportion in certain populations. So essentially, we can infer from that that different ethnic groups can expect to have different predispositions for diseases, as well as different drug response compared to other ethnic groups. So why is this important? Well, if we're able to take these types of things into consideration, basically these mutations for various groups, we're more likely able to provide personalized treatments that work for them, and while also avoiding any unwanted adverse effects. And traditionally, even though the pharmacogenomics field itself is still relatively in its infancy, accessibility to this kind of information for minority groups tends to be an arduous task. So unfortunately, this has created a bit of a health disparity, leaving minority groups largely underserved. So therefore, a central aim of this project was designing the foundation of a system that would ultimately help reduce this disparity. Okay, so in regards to system design, the cohort for this project chose to look at African Americans specifically. And the system itself has a literature-based design. So what does that mean? Basically, by looking at existing articles that have already considered or studied adverse drug gene reactions in this population, I was able to create an entity relational diagram, which you see there, which was kind of the building block for the backend database design. And just to clarify, when it came to inclusion of research, it was important that these sources met a couple necessary criteria, which basically was just the source needed to mention a specific polymorphism or SNP and a specific medication or molecule, and not just a medication class, for example. And then, obviously describe the adverse reaction in between them. And while, of course, this information retrieval process is ongoing. Using these consistencies across the literature, um, the goal was to make a functional web application that could be readily used by end users to query the database for any relevant pharmacogenomic information. And just to mention the building blocks that I used Python and a built-in framework known as Flask, which is a great tool for beginners like myself who want to design a system like this. And the database itself was coded in SQLite, which was the supported relational database structure for Flask. The front-end design currently only uses HTML and CSS, so still very basic in design, but still able to fulfill the needed requirements, and of course, room for improvement with future JavaScript applications. And it's important to mention that this system was designed in order to serve two main end user groups, and these being clinicians and researchers. And I'll talk in just a second about potential use cases for these groups, but it's important to note that while these groups would both greatly benefit from a system like this, it's important to consider their needs are different, and the way they would use the system is most likely going to be different as well. So in an effort to establish why AnalyzeMed serves as a meaningful health information system, several use cases were defined. So these three cases should not be considered an exhaustive list. However, because the system is still maturing, these are the primary cases the application has the capacity to serve at the time. So first, AnalyzeMed can help to facilitate better patient-provider communication. This is something I think everyone can relate to. Many times, consultations with doctors are either time restrictive, or perhaps a patient leaves more confused than when they arrived, or simply with just a lack of confidence about adhering to a prescribed treatment. So for example, a medical provider may need to improve patient understanding of adverse risks associated with a common treatment. And though that treatment may be common and work well in most cases, that patient could have a genetic predisposition that would result in an unwanted interaction, or maybe even just call for a much higher dosage, which could create problems on its own. So therefore, it could be necessary to seek other treatment options that are more aggressive or more expensive. And this, of course, would be undesirable to the patient, but a system like AnalyzeMed can help providers show patients descriptions and sources of studied interactions, as well as offer recommendations or viable alternatives. And hopefully this would leave patients feeling more confident and comfortable with their treatment. And another case, this system hopes to fulfill a clinical decision support component at some point. So the system could act in conjunction with an alerting system, possibly built into an EHR system, where certain molecules may raise alerts, and providers who use the AnalyzeMed system can determine better if a genetic profile test should be administered to that patient, which in turn can help determine what treatment options may be best. And then a third use case, again, the system was built for both providers and researchers. So, the third use case could be facilitating pharmacogenomic research. So basically, if a researcher wants to access a repository of drug gene information, that would hopefully provide a highly usable and intuitive platform. Researchers can go into AnalyzeMed and find relevant data to their respective queries. So for example, if a genetic researcher is studying the associations with a specific polymorphism, the system can help narrow down their search and provide accurate data for them. And so in order to help fulfill these mentioned use cases, the next system was defining system requirements. And overall, these requirements fell into two main categories, which were improved search function and improved data presentation. And again, this shouldn't be considered exhaustive, but definitely a good starting point to the overall application. So just to name a few, offering the ability to filter results after the initial query, providing ICD-10 code search help, sort of as a standardized way to search by medication class if that is the user's goal. Also the ability to search by a list of medications rather than just one at a time. For data presentation improvements, I want to improve the display of results to be, or the results page to be less verbose and more readable. I also want to add the ability to generate visualizations from the search results, and in turn, those can be shared with patients and improve understanding. And a final data presentation element could be the ability to download stored data, which could be especially useful from a researcher perspective. And here I just wanted to share a couple demonstrations of certain search elements that are available for the system right now. So this is a live version at analyzemed.unc.edu. So on the left, you're seeing the ability to search by a comma-separated list, and that demonstration just uses 2 medications, but you can certainly do as many as you like. The database itself isn't that large yet, but you can see that it returns the respective information. And on the right, if someone wants to search by medication class, for example, they can use the ICD-10 code help page to note the ICD-10 code that correlates to that medication class and search the database that way, and also get the necessary information that they need. And it's worth noting that right now the application is designed to be a CRUD application, which stands for create, read, update, or delete. But obviously in the future or the near future, it'll be good to make the ability to edit and delete certain components only available to administrative users. But looking forward, this information system, I believe, has a lot of potential. One of the ideas, more exciting ideas, is that it could be fully integrated into an EHR system, making it a much more useful CDS tool or clinical decision support tool. Additionally, from there, it would help lead to more personalized treatments, being able to factor in genetic variants and being able to assess which medications or dosage levels would be best. One of the ongoing functions is trying to automate the information retrieval process. So up to this point, data collection had been mostly done manually, which of course isn't ideal for hosting a system that hopes to hold all, if not most relevant data for its purpose. So currently, we're looking at tools like the BioPython package, which interacts with the PubMed and Medline APIs, and basically coming up with refined queries using mesh terms, such as African Americans, adverse reactions, stuff like that, to basically pull out all relevant articles that that can be transferred over to AnalyzeMed. And lastly, just to reiterate, the desire for the system, again, to be a service to clinicians and researchers. Moving forward, it's important to consider system improvements that I already discussed, but also focus on other ways to create an interface that separates these users, essentially, since they do have different needs and they'll likely be searching for different information and want to use different methods to do so. So consideration for that is important. And I just want to conclude that I thoroughly enjoyed working on this project. I'd like to thank Dr. Mustafa and all the other LAIR lab members who helped provide various expertise and input to help me create this web application, which is something I'd never done before. I learned a lot by designing my own pharmacogenomics system, but also learned a lot by studying other ones like PharmGKB from Stanford. And this project really helped me take my classroom knowledge and apply it, especially when it came to things like database design, information retrieval, and using programming languages like Python to create a functional information system. And yeah, I really did learn a lot, and I hope that for at least a little while, I can continue to have a hand in this project as newer students come in and take it over. And I just want to thank everyone here again for taking the time to be here and listen to me speak. And I'm happy to answer any questions that you might have. Thanks.